My topic is big data, and today I'd like to talk about the computing problems solving of big data and the computing tools and technology of big data. Computing problem solving of big data. I will introduce the technology root of big data first. Acquisition, transmission, storage, quality management, and problem solving. Acquisition is acquire massive amounts of data from the physical world, like sensors, mobile terminals, scientific instruments, and so on. Transmission is distributing data to different computers as required. For storage, the traditional data is generally stored in the database. Because of the extremely huge size, the storage of big data is different from the traditional one. Quality management. Due to the huge size of big data, there will inevitably be a lot of dirty data, which will affect the performance of big data analysis in the future. Problem solving is after the previous steps. Different solving algorithms are proposed to solve big data problems in different application scenarios. The solving process of big data problems needs to go through these steps: business researching, data preparing, data browsing, variable selecting, model defining, parameter calculating, and model evaluating. And now, I will introduce the solving process of big data in detail. The first step is to define the computing problem and judge if the problem can be computed, that is, to see if the problem can be solved by a computer. Next will be performing the computational feasibility analysis. All the problems are presumed to be computed, but due to various limitations, unfeasibility still exists, which mostly refers to the constraint of computer resources, tasks time, and the problem's data size. A computer whose hardware resources is not up to standard, but the size data is huge. Under these circumstances, it's hard to solve any problems. The next step is to design and analyze the algorithm. Design the algorithm at the theoretical level and finish proofs of all sides to guarantee the theoretical correctness of the algorithm. Then, the designed algorithm is implemented with the appropriate computer language and finally summarized into a software system. In the process of solving big data problems, the following problems may exist: resources limitation and real-time requirement. The resources limitation is insufficient memory and processor. For inefficient memory, what often happens to the big data problems is that dozens of gigabytes, even terabyte data is too huge to be stored in memory. Solution is external memory algorithm and the space sublinear algorithm. External memory algorithm is designing external algorithm with the help of the computer disk storage space, which helps on storing the huge amount of data but takes longer time. But the space sublinear algorithm may sacrifice the accuracy. For insufficient processor, the solution is upgrading the computer and parallel computing. For upgrading the computer, generally it's not easy to use this method because such a huge amount of data is hard to be computed through the limited upgrading of a single machine. And parallel computing is the mainstream way of the present time. Next problem is real-time requirement. That is, the lower limit of complexity of computation is hard to satisfy. The solution is time sublinear algorithm. This method improves efficiency but may sacrifice accuracy. There are some suggestions for big data computing. Using hardware and software platforms suitable for big data computing, or designing efficient storage structure of big data, like data storage structure, data distribution strategy, and data indexing method, and writing the computing programs suitable for big data, such as avoid using the system garbage collection mechanism, reduce memory copy, reduce the number of data redistribution and the amount of redistributed data. For the computing tools and technology of big data, first I would like to introduce the big data computing framework. Here are a few common computing frameworks that have their own focus. Data-centric computing framework, like Hadoop, Spark, and Hyrax. For the Hadoop is a distributed system infrastructure developed by Apache Foundation. Users can develop the distributed program even without knowing the underlying details of distribution. And for Spark, Apache Spark is a fast, general-purpose computing engine designed for huge-sized data processing. Spark is a Hadoop-like general-purpose parallel framework, often open source by UC Berkeley AMP Lab. Besides all advantages of Hadoop, Spark has its own unique merits. For streaming processing framework, we have Storm and Spark Streaming. Storm is a distributed real-time big data processing framework open source by Twitter, and is called the real-time Hadoop in the industry. And Spark Streaming is an extension of Spark Core API, able to achieve high data throughput and fault-tolerant real-time streaming data processing. For distributed graph computing framework, we have Pregel, PregelX, and GraphX. Pregel is a parallel graph processing system based on BSP model to solve the distributed computing problems of large graphs. Pregel built an extensible and fault-tolerant platform, which provides a series of flexible API being able to describe various graph computing. GraphX is a distributed graph computing framework, which is based on the Spark platform and provides concise and easy-to-use interface for graph computing and mining, greatly fulfills the need for distributed graph processing. For DFS, we have HDFS and GFS. HDFS is Hadoop Distributed File System. Is implemented by Hadoop with HDFS as one of its components. It's highly fault-tolerant and designed to be developed on the low-cost hardware. It provides a high throughput, accessing up to the data of applications, which fulfill those ones with a large data set. Now I'm going to talk about the design and analysis of big data algorithm. When we design big data algorithm, we need to consider the following situation. Because the polynomial time algorithm often cannot meet the requirements, to achieve linear and sublinear, we can choose a random algorithm. Memory is insufficient, so we can use external storage algorithm. Because of the large scale of the algorithm, it's necessary to design parallel algorithm, and due to the lack of knowledge, crowdsourcing techniques should be considered. When we analyze big data algorithm, we need to make trade-offs between efficiency, resources, and accuracy. For example, sublinear algorithm often compromises between efficiency and accuracy. For quality management of data, big data has the features of large capacity, producing fast and having many kinds, so it is more likely to cause data quality problems, and poor quality data misleads the result of analysis. Therefore, when we carry out data quality management, we need to consider the measurement and evaluation of data quality, the testing of data quality problems, and the data cleansing. Next, I'll talk about data security and privacy. Security and privacy are very important for the safety and legal applications, and have attracted the attention of enterprises and academia. For data security technologies, we use encryption algorithms that support query and analysis. For data privacy protection technology, we use anonymous or differential privacy protection. Although big data technology has been highly developed, we still face some new problems, such as the complexity theory of big data computing in time, space, energy consumption, and communication. Algorithm design methodology, theory, and method of big data quality management and acquisition. The theory and method of big data problem solving, managing, and service platform for big data, and application-oriented computing theory and the algorithm for big data. Thanks for listening.